Good afternoon. I'm Atsushi Miyazawa. Today, I'll show how a well-known five-point circle puzzle turns into a clean, projective conformal result, a radius zero circle. In the complex projective plane, the punchline disappears. A theorem appears. Draw a circle that passes through these five points. In Japan, that the usual response is to draw the kanji character n like this. A linguistic joke rather than a geometric answer. Let's push beyond the joke. Okay. So the claim is that there is a mathematically meaningful resolution, just not in purely Euclidean terms. The configuration is not Euclidean concyclic, but it is complex concyclic. When we step into CP2, the complex projective space, complex projective space. So here's the first twist. The round circle. Okay, screw it. Round circle. Round circle and cross. Circle and cross. And the two real lines meeting are not homeomorphic. Topology keeps them apart. Yet, projectively, they can be members of the same pencil of conics. This is a Japanese custom. Okay, we usually say, uh, shown a circle for yes and a cross for no. This is Japanese custom. A little bit different or lesson style. Okay, so the configuration is not equal to concyclic, but it is a complex concyclic when we step into a simple. Okay, I read it. And here is the first twist. Topology keeps them apart, yet projectively they can be member of the same principle of conics with a cross, a degenerate member. This is a sense in which same family, different topology holds. Okay, so in CP2 defines a circle as a conic that passes through the circular points at infinity, often denoted as capital I and capital J, I and J. I equal 1 to I to 0 in a homogeneous coordinate. And capital J is 1 to minus I to 0, also in homogeneous coordinates. So if we reinterpret cross as an imaginary pair, y equal plus minus ix. So circle and cross become complex concyclic. They share the same projective signature. Those two points are at infinity. Okay. So five spot buckets. Why does five spot pick up the cross? Each diagonal contains three of the 5 points, right? A conic meeting a line in 3 points must contain the line. Hence, a unique conic through all 5 points, split at two diagonals, the cross, over C, C complex plane, complex number plane, will rotate the vertical coordinate by I and see the radius zero circle emerge. Okay, so okay. So to visualize how real and complex views interleave, we use conic tomography. Work in R4 congruent to C2 with x, y, u, and b, or z equal x plus iy, W equal U and U plus IB. This is a usual convention for complex analysis. Keep two intrinsic complex planes. P, X, Y, the Z plane. Uh, this normal Gaussian plane of Z. Then the P, U, B, the W plane, the image plane, it's mapping. Then there are mixed or composite planes. Composite is a yeah, my original naming. But PXB, real and imaginary. PYU, imaginary and real. PXU, real and real. The PYB, and imaginary and imaginary. So, so I made a wait a second. Yes, Ethereum branches. Okay. Last time, not the last time, 22 3 WTC, I presented the Ethereum branches. And if you like, please look at the YouTube videos. Okay, so the workflow is first, complexify the conic. Second, take hyperplane cuts of R4. Third, in each 3D slice, extract the real branches that actually appear. These real branches are what I call Ethereum branches. In this context, you know, it's for a point circle. X squared plus y squared equals 0. Ethereum branches manifest as the imaginary line pair when viewed in composite planes. But they collapse to a point, the point circle in the intrinsic Z plane. This gives an interpretable slice by slice picture of how the degenerate conic behave across viewpoints. But here's the two lenses, figure and shadow. This terminology is okay. My motivation is what is the appropriate and smart name for classic geometry. So okay, let me name the two lenses explicitly. Linear geometry sets do not stretch, move, scale, invert, project, trace invariants, and the shadow geometry are actually projective geometry. Shadow geometry sets think projectively. Incidence and cross ratio organize the picture. A 5-spot story needs both lenses. Okay, I think this is a interesting point also for you. I asked this question, is in contrast to topology, So, because of topology, please provide a striking phrase that encapsulates the classical geometry that preceded it. That is the geometry from the Greek era up to Carl von Stautz's complex projective geometry and Klein's Range program, which ultimately lays the foundation for introducing the idea of abstraction into mathematics. Yeah, first I asked this question to ChatGPT, GPT-5 thinking. He or she, I don't know. He returned a storm and shadow geometry. And then the same question to throw to Gemini Pro, and he praises the output of the ChatGPT, Stone and Shadow. But for me, Stone is a bit Strange. It sounds strange because stone reminds me of the Stone Age. And finally, I asked this exact the same question to Wolfram, notebook assistant to plus LLM kit. This is the result. He answered, geometry of shapes and shadows. This is great. This is great. I inspired a lot. So okay, I made a conversation like this. So finally, my geometry figure the shadow. What about this? So yeah, he said yes. And also in Japanese, Pearson's shadows had a special meaning. Keisho. K means fear, A shadow. Yeah. Okay. I will upload this file to Google Cloud. So please look at it if you have time. So anyway, let's. Yes. So topology is right to say circle and cross are not the same kind of object, but here's and the shadows explains why they still cohabit on conic pencil. The invariants, circular points, I and j, coaxial permanence, a reality of the cross ratio for 4 points, holds the narrative together. This is where the puzzle stops being a joke and starts being a geometry. Yeah, okay. Now the algebra. In general, 5 distinct points impose 5 linear conditions on the 6 homogeneous coefficients of a conic, fixing it up to scale. In the 5 spot, each diagonal carries 3 points, right? 3 points, 3 points, 3 points. And the linear over oh in the 5 spot. Hence, the unique conic is reducible. The union of the two diagonals over C, complex plane, number plane, not a complex plane, complex number plane. The linear change xy maps to xiy. The union of the two diagonals over C. The linear uh, uh, maps to xiy since those lines to y equal plus minus ix, which is the factorization of the 2 square plus y square equals 0. That is the radius 0 circle. Yes. Let me standardize language. A radius 0 circle, point circle, satisfies x square plus y square equals 0. A set is complex-concyclic uh, if it lies on a conic through I and j, chapter I and chapter j. For 4 points, Möbius concyclic reduces to the cross ratio being real. For Möbius invariant, we can compute quickly, right? Okay, here's visualization of the I and j. In homogeneous coordinates, a Euclidean circle has a form ax squared plus y squared plus dxz plus eyz plus fz squared equals 0. Intersect with a line at infinity, z equals 0. We always get I and j, right? The circular points at infinity. The circular points at infinity is not complete. Imagine imprecise imaginary circular projectivity, right? Okay, so in this sense, all circle passes through the same 2 points at infinity. That fixed pair is the center of the circleness in the projective world. Okay, so this is this series of diagrams in a visual for I and J that I presented at WTC 2020, uh, 5 years ago. Yes, this one. Yes, yeah, this one. Come see the points at infinity. And J over E. Okay, so in contrast, this is a diagram by GPT-5 thinking. It's so terrible that they are unusable, or we can say garbage. You know, this means there's still a room for LLM to generate a diagram, a mathematical diagram. Uh, they are have been investigated. Okay, so yes, this reframes lines and circles as a single coaxial pencil through I and J. The five spot, far from being a linguistic trick, is an existence and equivalence sentence in CP2, not Euclidean concyclic, but complex-concyclic. So, yes. So, pedagogically, the contrast 3 points for a non-degenerate circle versus 5 points forcing degeneracy is memorable, right? At Cayley transforms variant branches and a glimpse of the IJ visualization, you can bridge from puzzle to projective ideas without heavy prerequisites. Okay, so this is my okay, I want to investigate this what to call that equidistant chart. That's a previous this my visual or the point at circular points at infinity. We can convert this to equidistant imagery. So with this, what I want to say is, you know, uh, yes, the possibility of an immersive virtual environment for the visualization of complex and or infinitely distant territory. So we can expand the 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 territory of the normal VR from Euclidean space to a complex projective space. So then we can find the uh, element of the finite domain and element in a infinite domain at the same time. Yes, this is just what I want to do in the near future. Yes. So, 3 lines to remember. Don't stretch, move, scale, invert, project, track invariants. This is the classic geometry style. The no circle turns into a radius zero circle. 5 points, not Euclidean concyclic, but complex concyclic. Yes. Thanks to collaborators in the WTC committee. I also thank ChatGPT GPT-5 Thinking, Gemini 2.5 Pro, and don't forget this Wolfram Notebook Assistant plus LLM Kit. Yes, this is the end of my presentation. Thank you very much. If you have a question, please send me a mail. Okay, I'll give you an answer back. Uh, Thanks for thanks for joining. Thank you very much. Bye bye.